What's going on, everyone? It's Jared. We are doing an assembly video today of the Galileo 2 Z drive, but in this case we're doing the XL drive. So one of the main differences, there's only two primary differences between this and the standard G2Z kit. One of them is the new part number, which is LDO42STH40 1684AC, so that is a fairly common part number. And then in parentheses at the end, we've got RSS9T. So that's the kind of magic, if you will. That is a rubber seal and a 9-tooth spur gear on there. So that is our sun gear. Effectively the same thing as the NEMA 14 stepper as far as the 9-tooth and the size goes. I'll show you that in a minute. The other big thing is it now has 4 M3x35 socket head cap screws, and that is to hold the whole stepper combination together. So I do actually have a NEMA 14 version of the Galileo 2 stepper, and I can kind of give you a quick side-by-side here just to show you a little bit. You'll see the 17, obviously it's larger. The 14 does have 2 of the same mounting holes that the 17 does. So if you can imagine, the 14 over here has 2 more flared edges out for mounting that would mount up exactly the same as the NEMA 17 would. The little lip on the 17 is bigger than the lip on the 14, obviously. That is accounted for with the printed part. And then here's the magic on the XL stepper, if you will, which is that rubber seal. And what that does is it greatly increases the detent torque. So this is what allows your 350 gantry, even a 300 Trident bed with 3 kilograms of filament on the bed by way of Telzoid. He did a little testing with that. It'll hold that up without dropping when the motors go off. So you have this rubber seal adding a lot of detent torque, and then that's also going through a 9-to-1 gearbox. So you've got 9 times whatever this actually is before you're able to move it. What that does also mean is these are fairly hard to back drive. Some would say they're not able to back drive them. With 9mm belts on the Z, you should be able to back drive them enough to get things moved out of the way, but I would suggest not moving them by hand if you can avoid it. Best way to do it is to do like a force move in clipper so that it's using the electronics to move everything along. If you have to move it, you got to do what you got to do, but it will be very difficult. And we'll go over a couple of things later that also makes alignment a little bit harder as well for the carrier and the planetary gears onto the sun here, because you can't easily rotate it one full rotation to check like you can with the extruder. So we'll get to that in a bit. For now, let's go ahead and get started on assembly. You will notice that I do actually have the MR148 bearing already down in here, and the reason for that is I've already made this video once today, and my phone decided that it no longer had enough storage, even though it's got plenty of storage. So I'm recording to an external device at this point with hopes that it does what it's supposed to. So this is the main corner block piece. This is what will go, this is what holds everything together effectively. So this corner block piece, there are 4 of them. They will hold the steppers, they'll hold the carrier shafts and all the rest of it. Where my finger is here, down there is where the belts will be on each of the corners as well. So to start with, I'm just going to go ahead and put the MR148 bearing down in here, and that's mostly so I don't forget it. You can also go the other route with this and put it on the end of the carrier shaft, but I like seating it in here so that I know that it's all the way seated, just for a little peace of mind. So with that out of the way, we are going to go ahead and get this mounted. And the kit does come with everything that you need for this. So this kit assumes that you're coming from a V2 with your standard V2 corners on there. Maybe you don't have the extra hardware laying around, so it does even include the roll-in T-nuts. So I do have both of these installed. There's one in here, which this will be along the bottom section of the frame. So this is going to be effectively pointing down towards your table that the printer is sitting on, and this will be on the inside. Now, if you're retrofitting these, this little guy can be very hard to get in because this is where your electronics bay is in here. You're going to have all your junk sticking up this way, so it's going to be hard to get in there. A good ball end, Allen wrench, hex tool, whatever you want to call it, will significantly help in getting this together. So I already have this where it belongs, but if you've got stuff in the way, drop in the roll-in further this way, slide it along, kind of get it where you need it. And then once you go to put everything together, your easiest bet is to most likely use some sort of a swivel hex. So that is where that one will end up going. So speaking of putting into place, let's go ahead and get this into place. These are going to be M5 by 10 socket head cap screws, pretty standard. We're going to have one in the side here. I'll go ahead and put that one in first. And then I'm going to try to keep everything in frame here, but since I'm working up towards the camera, it's going to be a little bit hard to keep everything kind of happy without doing exactly what I'm doing right now, which is just getting everything from the screwdriver and nothing from what I'm actually trying to shoot. So you'll have to bear with me a little bit. Do as I say, not as I do. I am not using a swivel-ended hex here, and I'm doing that so that I can do things one-handed and manipulate things and keep the screw on there. But this screw will be the harder one to get in. So once you get that in place and tightened down, that is the main assembly for the corner bracket here. So without moving my camera and shaking the whole table here, that's nice and firm. So one other thing you'll notice is I do have 2 heat set inserts installed in here. Those are the only 2 that you will use for G2Z XL. On the regular G2Z, 2 of these, if you look from this side, 2 of these, the ones that are recessed, are not through hole. They actually have spots for heat sets on them, and that's because, as we talked about before, the NEMA 14 motor only has 2 mount points. So whenever that would go together with this, you would end up with something kind of along those lines, where the other 2 would end up being just heat sets. So in this case, NEMA 17, we're using all 4. That's why we are not using the other 2 heat sets in those. And it's just one of the things that had to happen. But with this setup, those M3 by 35, they do come with the kit. If you are trying to retrofit from a regular G2Z to a G2Z XL, you will need to buy these separately if you're not buying the full kit. So I know Jason's making the steppers available separately for the people that just want to upgrade. You will need the M3 by 35 screws. So that is the biggest kicker. And the reason why we did that is wanted to have one corner block for everything. So this will do G2Z and G2Z XL. And in order to do that, I had to work with the fastener sizes rather than adjusting the printed parts in this case. So trying to keep bill of materials and everything down, but also trying to keep everything reasonable. So moving on, we have the back plate here. Not actually a back plate. This is where the carrier recesses. So this is part of the corner. One thing you'll have seen a second ago is there is actually a number 1 on this corner. And that number 1 on this corner matches with a number 1 on this corner, which if I can flip this over and maneuver it just so, you can just make out the 1 down there. And the goal of that is, pardon my hand, well, tried and failed anyway. So I'll go from the bottom. With all that together, you see the 1s line up. So it makes it easier for assembly because the 2 different sides are different. And the main difference on those comes down to these 3 screws. And that's going to depend on what side you're on. So with the 1 on top, you've got 2 screws on top, 1 screw on bottom. The reason for that is this pulley, when it's installed, will actually kind of interfere with those screws. And if those screws are just willy-nilly wherever they want to be, they can actually cause issues with the pulley side and getting the belts and everything seated. So there is a difference on the 2 sides. Just match number to number. You'll be fine. So the other thing with this, we have a second MR148 bearing. So there are only 2 used in Galileo 2Z and Galileo 2Z XL. One is already in our front block. The other one goes in here. Now, the interesting part with this is not retained in either direction. So I can push it all the way through from either side. So how do we fix that? Well, we use the same system that we used on G2E for the backside. So without having the bearing in here, we can go ahead and put 3 screws in. Now, again, this is the second time today that I've done this, so these screws are already threaded, so it's fairly easy for me, but you will have to thread them the first time that you screw into them. Make sure you don't strip them out. It's just threaded into plastic, and it's fairly thin plastic in this case. So just keep everything as easy as you can without stripping it out, because if you strip it out, it's going to be a bad time, because that is the only thing that keeps the bearing from falling into the gearbox side of things. So, and I will show you in just a minute once this third one is installed. All right, just snug. So we're going to take our bearing now, and you'll see that the screws on the backside do actually protrude a little bit, like I was talking about. They can interfere with the belts if they're in the wrong spot. So if you try to put 2 on the other side, these will be rotated a certain a certain amount, effectively 90 degrees, if I recall correctly. And that's just down to being able to rotate the steppers the correct direction to keep all the wires internal. So it's all a bit technical, if you will, but basically that's what we had to do. So for the MR148 bearing, just line it up, keep it as flat as you can. It's going to be a little bit tilted, but push it all the way down, push it in. So you'll notice it now has a positive backstop. That's because of these 3 screws. So even though it seems like, hey, these screws aren't even touching, they're not even doing anything because they're so just close to that edge, it doesn't look like they're even doing anything, they are holding that bearing in. So from this point, what we're going to do is we're going to install our carrier. So on our carrier, I don't think I can pull this very easily to show you. Maybe I can. There we go. I do have one of our shims. So there are 4 shims included, but these are our 8 by 11 by 0.5 millimeter shim washer. There's 4 in the kit. 3 of them will be used for G2Z or G2Z XL. The reason why there's 4 in the kit is Jason's just kind of consolidating everything down to smaller kit sizes. So easier to have a couple extra pieces in one than to try to stock and keep track of additionals. So there'll be some extra screws, there'll be some extra parts, not a big deal. So now that we have the shim washer on here, we are going to go ahead and install that into this guy. Now with that installed onto this guy, if you press too far forward, you can actually lock the carrier in between the screws, and that's because the bearing has nothing to retain it on the backside, as we talked about. So to get that where we want it, just make sure that the bearing is pushed down. Now the tricky part here, so we're going to do one more shim on this side. It doesn't matter which way you go with it. There's kind of a smooth side and a rough side to the shims. It doesn't matter on those because once this is all assembled, these will all be rotating together. So put them whichever way you feel comfortable with. And they can be a little hard to get down the carrier shaft sometimes if you get them just slightly off kilter. What I like to do is put them flat against the bearing, then push the carrier in. So that does a lot of good. What we'll do from there is we will install the pulley. Now this is a semi-custom pulley, if you will. I actually had found some pulleys that worked for this straight off the shelf, and they were marked as being like Prusa style. I bought them on Amazon, and I couldn't tell you who exactly made them, but these are 19 millimeter overall depth. That's the biggest thing with those. So if you ever need to get replacements, the biggest thing is that they're 19 millimeters from top to bottom. Most of them are 20 or potentially even taller than that, and we really needed the 19 millimeter overall size. So with these together, we need to kind of clamp these together with our fingers. So the carrier shaft, I want to make sure that this carrier shaft is being pushed this way, and I want to make sure that the pulley is being pushed this way so that we get a tight sandwich with everything that's on here. I also want to make sure that my flat on my carrier is aligned properly with the set screw on my pulley. So I'll go ahead and tighten that down. Once you get that tight, you can just kind of let everything go a little bit. We'll get the side screw tightened down. Good to go. Now, you can still move the plastic piece around on here. So it is still possible to jam up this side of it. You don't want to jam up that side of it. We want to push that side of it to keep everything running smooth. Whenever this is all installed together, this will naturally push itself from this side against the bearing and the shim that's going to be on this side. So once it's together, it's not a big deal. It's just the assembly process. It can be a bit of a pain. Speaking of shims, go ahead and put the last shim on there. Now from this point, you want to basically assemble the 4 corners. So you want to get to this same point on all 4 corners, and then we're going to come through and we're going to install this side. So what we're going to do here, and I'll tilt this up to just kind of show you. Right here is the belt path. So this is where your Z-belts come into. So what you want to do if you're retrofitting and you've already got existing Z-belts is you'll want to put that Z-belt down into here, and you want to put it in a spot where you can get this pulley kind of around and into that, so you can seat it kind of in the middle. If you're doing this brand new and you don't have any Z-belts yet, honestly, it doesn't make a ton of difference because this is a nice smooth path. You can push it down through and it'll come back out the top. It's very easy to thread through that way, but I would still suggest if you can do it, just put a loop down in there and then go ahead and push the rest of it in. I did lose my my top shim, so I'll put that back in place. We're going to drop this back down just to make this a little bit easier. And then, since this is now upside down, I want to find that 1 that I have, which is right here, and I want to put that at the bottom, because that'll match up with the one that's on the bottom. Now, your belts will be in here, you're going to slide the pulley in, and then you're going to fully seat that on the corner block here. Now, as I've shown before, I'll go ahead and pull it apart and show it again. Just like regular G2Z, there are 2 tapered holes here, and those actually match with the tapered edges here. So this will hold itself in place once you put it all together. So it's not just going to fall off. The carrier is holding it, but the little things are also holding it, both in rotation and in just general placing. So it's not going to fall apart too easily like it is. I do still recommend trying to put like 1 screw through just to kind of hold everything together. So 1 M3 by 35, and I'm just going to push that through. And the reason for that is, even though we have it all together, there can still be a little bit of wiggle, and if you're trying to like mess with the belts and kind of get that all adjusted, it doesn't hurt to have something holding in place. Honestly, you could put all 4 screws in if you want to. It's not going to hurt having them in there. Might just make it a little bit more challenging to try to get the rest of the part on here a little bit later. So as we get to that, you want to get all 4 corners to this point, as mentioned. You want to get all your belts ran. You want to have everything 100% done. The reason for that is how difficult the system is to backdrive. You want to get your gantry at a spot where you're happy with it. Either tape the gantry in place with some Kapton tape or something. Keep it from moving in about the right spot, and then come back and we'll basically put the steppers on once you get to that point. So I'm going to assume that I've got all 4 corners done. I've got the belts ran. Everything's done there. We are ready for assembly. So I'm going to take my adapter bracket. This is only used for the NEMA 17 setup. I'm going to take my injection molded ring gear housing, and it only fits in technically 2 ways, rotated 180 degrees, but these 2 corner pieces won't fit in. It will drop in the rest of it. This part should drop in. It should have a little bit of resistance where it's not going to fall out. If it's a little bit on the looser side, that's okay, because it will be held captive by both the stepper and the front half via the little tabs here. If it's too tight and it actually deforms, you need to check your settings and print it again, because too tight can potentially cause problems if it's actually clamping the gearbox, which we don't want. And if you end up having some weird things because of how tight this is, it's really hard to troubleshoot, because it's not a common thing to see. So it's not a common thing to know, hey, how tight was the adapter plate for you? So just keep that in mind. If it's too tight, whenever it's going together, it's going to be too tight whenever everything's trying to go, and it will cause problems. So I'm going to go ahead and take the planetary gears, which I've already put the MR115 bearings in, and I'm going to just set them onto the carrier here. Now, I am not putting grease in because this is just an assembly video, but you will typically want to put just like a pea-sized dot of grease in the gearbox side, and that mostly just keeps everything quiet. At this point, we're using injection molded Delrin gears, and it's a fairly smooth surface that it runs together on, so it's not too big of a deal on that side. Now, this setup can only go 2 directions, so 180 degrees. There is no identifying marker or anything on here because it can go 180 degrees, but it matches the little fins that are on here that would normally keep it on regular G2Z. So it will only go together 2 ways. So you'll see on the side, see if I can show you. We've got the little slots on either side. So we're going to match the slots from either side of here onto the slots on either side of there. And we will set that together. Now this is where the screw is actually going to hinder me a little bit. So I'm going to push that screw back in a little. And we are going to realign this. So drop that in all together. Now, once it's all together, I can go ahead and take my screwdriver and just push that back the rest of the way through. So it may be a little bit hard to kind of get all this together, especially if you're trying to retrofit and work around electronics and such. And until this gets clamped, that screw doesn't come through a whole large distance on the backside, but it will be enough to catch the stepper. So, and the stepper is the next part. This is the hardest part of G2Z XL, and that's because, again, like G2Z and G2E and everything that's using the G2 gearbox, you can't align it a tooth off. And if you do that, it's going to cause you problems. And the best way to get it aligned is to just rotate and wiggle until it falls into place. Now, that fell into place pretty easily. That is how it's supposed to be. If it has any amount of force whenever it's going into place, it's going to have a problem. So if it's, oh, yeah, oh, no, there's just a little bit. Nope, you probably have it misaligned. Pull it off, rotate the tooth one tooth, and then try it again. You can also try, especially if you've got all your belts tensioned at this point, you can try rotating the belts a little bit, because rotating the belts will actually rotate the carrier and the housing. And when you rotate it kind of all together, that can help you. So I'll actually show you trying to do it this way with using my finger as if it were a belt to kind of rotate all that. Fell right into place. So rotate it back to its side. I'm going to hold the stepper in place just so it doesn't fall off. That should be what your sandwich stack looks like. You want to make sure your connector is inside the compartment. Once it is, I do have that one screw in there. I will go ahead and just get that one screw started. Once the one screw is started, we're going to go through, we're going to get the other 3 screws started. And then once all 4 of them are started, we'll go back through and snug them all up. We want to make sure that we get them all in there, make sure that our alignment is proper with the gearbox and everything before we overly tighten anything. All right, all 4 are in there. Go through and snug those up. I like to do a crisscross pattern, but it's not super critical. Okay, once you're at this point, you want to go through all 4 corners and get all 4 corners to this exact same point. If there's any question on that stepper, rotate it around. If you can use your belt to get one full rotation out of this setup, to make sure you don't have any binding, that would be ideal, but with as difficult as it is to back drive, it may not be possible. So if it falls in super easy, you're probably okay. But I would highly suggest once you get to this point, if you have the ability to, test the Z drives, go all the way up and down your printer. If you hear any weird noises, if you see anything where it's like not working exactly like it's supposed to, go back, double check the corners, do it again. So once you're to this point on all 4 corners, and it'll set flat on here, now we need to start putting the actual corner pieces on. So this is very similar to the Trident part. It's been a little modified to fit with our design for everything else here. It's also been modified so that these 2 screw holes will match these 2 threaded inserts, because those 2 and this one setup here are the only things that hold this corner onto it. Now it holds it nice and secure, especially since we're way up here on the 2 screws, so the lever arm from that side is very small, which means we've got a good amount of force, but it is still a consideration. So we want to make sure that we consider that. Now moving to the corner piece, I am going to go ahead and put the accent piece on first. And these are effectively the same accent corner pieces as Trident, except they are designed to use flathead cap screws. So in Steve's design, he used the button head cap screws because that's what we were using in the bill of materials for the printer on Trident already. And it was just as easy to continue using that. But in G2Z, G2E, basically everything Galileo 2, we use flathead cap screws for a lot of things. So instead of adding an additional bill of materials item for Jason's side, I just went ahead and adapted these to use flathead cap screws. So one less item on the bill of materials, one less thing for the kit as far as complexity goes, so a little easier for the end user. And if I'm entirely honest, I kind of like how flush they end up being, to where you really can't see them. On the button head cap screws, you can kind of just barely see them if you're, looking at eye level, if you will, with the edge of it. So with these, you can't see the screws at all. They are recessed in there nicely. Everything's good to go from there. Now, I did not install the M3 roll-in T-nut that is required for this one. So let me get the M3 roll-in T-nut. There's 2 pieces in here. We're only going to use one of those. Grab my scissors here to cut that bag open. And we will take out one of the M3s. Now, depending on how you have this, there should be enough room to put the threaded cert in this way so that it's kind of hiding everything there. But if you need to flip it around, this is going to be on the bottom of the printer. It's not going to be easy to see, and you're going to have skirts over it, so most likely you're not going to see it anyway. But it is a consideration to be had when you're doing the assembly on this guy. So this guy is actually a little bit tight. I'm going to roll it in from the end. least I'm going to attempt to roll it in from the end. Okay. Well, let me try the other one to see if that's any looser. So this is a new frame. So I'm trying not to beat it up or anything. Yeah, that one goes in a lot easier. So that one is popped into place. That one rolls in. So what we're going to do is we're going to come in here, kind of push it into place, eyeball it. That should be pretty good. I don't know how well you can see down into there. Keep that in place for where it's at. Now, we're going to use an M3x8 socket head cap screw to mount that. So 3x8 socket head cap screw. And that's going to be just for the frame side. So we'll take this guy. I will put the screw in this side first to make it a little bit easier on myself. 2.5 millimeter hex driver. And I will just lightly snug that down. I don't want it super tight, but it should be tight enough. Now, onto here. These are M3x16s. So the M3x16s, we've got socket cap screw, 3x16. There's 6 pieces included here. We are going to be using a couple of them, not all of them. So normally on regular G2Z, you will have 2 of them in the front that you use because the NEMA 14 stepper only has 2 mounts to it. In this case, we're using 35s on that, so you're only going to use the 2 16s here. And see if we can get that to line up. There's the first one. Oh, you know what? I almost made a mistake there. We wouldn't be able to get the rubber foot on. We need to add the M5 nut first. So let's go ahead and take these back out. And I know somebody was yelling at the screen saying, "Hey, stupid, you forgot that." So I appreciate you. I heard it. Okay, let me get these guys. Hex nut, M5. So that hex nut is going to hold the foot in. And one more note about that foot, which you may have noticed in the earlier images, is there is a bit of a spacer in there. So M5 nut, we're going to drop that into place. Sits down in there nicely. Now the hard part here, since I'm working upside down, you are probably working upside down too, is trying to get this to not fall out. Now, I do have an idea of using like a printed shim or a printed spacer, if you will, to keep this further down and potentially make it like a slight wedge shape so it sticks in there and stays in there. Makes it a little easier. I haven't done it yet, but it's something that I do have kind of on the table. So what I'm going to do to prevent this thing from falling out is take one of my M5x16s, which is what's going to be used for the foot, and I'm going to temporarily install that in the bottom. So the bottom where that goes doesn't need to be all the way in, just needs a thread or two to catch so that it holds that. And then I'm going to flip the whole thing over, and I'm going to set it in place. So now you can see that that wiggles in and out a little bit, but it is in place. And I'm actually going to go ahead and put these 16s in first so they fall into the heat set in the appropriate location here. Apologies for the screwdriver in the way. All right, get both of those screwed in place and snug down. Get the M3x8 down here, or attempt to anyway. Try that again. M3x8. Snug down. Okay. Now, this thing is almost done. We'll go back to the rubber foot. Now, I'm going to push this out so I can show you here. This rubber foot actually has an M6 hole in the middle of it. And that can cause a bit, well, it's designed for M6 screws, we'll say. So it's larger than an M6 on the hole side. So what I ended up doing is creating a spacer, or kind of a shim, if you will, that fits down into there that allows an M5 to fit nicely so that it doesn't wiggle around and potentially come out, because the head of an M5 screw, which I have one here I can show you, this is a by 10, but the head of an M5 screw is almost the same size as that hole. So it's possible that that could get shifted off to one side and then have a bit of a gap. So basically, to avoid all of that, I wanted to use this foot because it's a little bit of a nicer rubber. It's a better material than some of the other ones that we've used. Just take this little spacer in there and just push it flat with the metal on this side. It's going to kind of protrude a little bit on the back side, maybe. There's a little bit of a kind of a swell that happens on the back of this kind of as it comes up. That'll be squished down, and then it also acts as a positive stop for the screw so that you can only bolt it in so far. So I'm going to take the screw back out of here, and for these feet, they can be a little tight at the top. What I normally do is I set them in sideways, and then I kind of roll them into place. And when you roll them into place, they kind of fall in pretty easily. Now, that nut is fairly far down. So the whole distance on here, there's probably 6 or 7 millimeters worth of space for that nut to fall into, which can make that kind of hard. So if I just try to screw this in right now, which I hope you can just barely see on the edge of the screen, it's not really going to do anything because it doesn't have anything to grip from. This is also why I'm looking at that option for the other side. So what you may have to do is kind of put the printer on the side, wiggle it down a little maybe, and then just try to get a thread or two started on the M5 nut. Hope you get it. Doesn't look like I did in this case. So I'm gonna go back again. I'm actually gonna pick it upside down as if it were on the ground, or the printer was, you know, sitting upright, if you will. And I'm going to try to get that M5 bolt, or the nut rather, to line up properly with it. Not sure how well you can hear any of that, but it did get tight. So gravity is your friend in that case. If you have any way of having gravity be your friend, use it. But it is tightened on here. Like I say, I may push a little time and effort into just keeping that wedged up to make it easier. Everything else is designed to be easy. Might as well fit that along with it. Like I said, those parts were based on Trident, so I didn't modify them too much in that regard, but it definitely helps. So this is the completed G2Z XL corner. I can't give you a great view because of how the camera is mounted. It's on a tripod at the moment. But let me see if I can do it. No, not really. About the only way I could do it is if I took off. Here, I can do that. I will take off the blind joint real quick on the side of this. And I will take off one of the mounting points just so we can get a better view of what it looks like. Also taking out the M3x8 front screw. Okay. Thank you for bearing with me. So here you go. So this is the finished look, if you will. Mind you, I did not run a heat gun across these parts, so this part was printed along the bed. You've got a little bit of that ABS haze that shows up. Smacking that with a heat gun would immediately cause that to just disappear. But here is the overall look. Fairly clean. Try to keep it as simple as I could. The only thing, again, being that M5x16 is a bit of a pain, so I think a printed spacer that's in there would probably be the best idea. I'm just trying to figure out the best way to go about it. So originally on the original beta, I don't know how well this is going to translate across camera, but there was a little gap right here. Now there's still the tiniest little bit of gap, just because there's 2 printed parts, but now this part actually slopes out to meet it, and that was actually done by another member of the Voron community, whose name escapes me at the moment, so I apologize for not throwing your name in there, but basically I had a little bit of help with this in form and function, if you will, as far as getting it to the point where it's at, where it looks, nice for release. So, and we are just about at release, so that will be the next step with this. But there's G2Z XL. It is now a 35-minute assembly video, so thank you for sticking with me the whole way here. If you have any questions, please post them on Discord. I will get to questions that are posted on YouTube, but I do have a significantly larger group of people that can help on the Discord. So it is the Voron official Discord. There are channels for Galileo, which does include both Galileo 1 and Galileo 2. So if you've got any questions with anything, let me know. Otherwise, you should be set up for a G2Z. So the biggest difference between G2Z XL and G2Z is just the assembly steps. So with a regular G2Z, you can fully assemble the whole corner piece here, the whole main block, and then install that kind of all together. With G2Z XL, because you don't have access to this screw once everything's all done, you kind of have to do things in order. And because of this stepper, with how much force it has and how hard it is to back drive, aligning everything and doing everything with the carrier first really does make a big difference. So that's just about all I got, though. Again, any questions, please direct them to Discord. I will answer anything that pops up on YouTube, but it may take me a bit more time to get to. And then as far as kits go, LDO makes the only official kit for this. You can get the official LDO kits on AliExpress via TL and Mellow, I believe, stores. All of that is on my GitHub. It is github.com/JaredC01. And then you can click on the Galileo 2 repository to take you to everything that's included on that as far as the vendors list. So it is on the main page for Galileo 2. So that's all I got for you. We will see you guys next time.